Welcome to Innovation and Leadership. I'm Jess Larson. Today on the show, we've got folks from the Stanford Computational Imaging Lab.
So the idea is that we have digital or electronic eyeglasses in the future. Simply, eyeglasses are really great today for correcting nearsightedness and farsightedness, but they're not very good at correcting presbyopia. And young people don't really think about this much because it starts affecting people when they're about in their mid or late 40s or early 50s, but you can't escape from it.
Nitish and Gordon, why don't you guys both introduce yourselves?
Sure. I'm Nitish Padmanabhan. I'm a fourth-year PhD student working at Stanford in the Computational Imaging Lab. We work a lot on vision correction, focus key supporting display technologies, and also correction for presbyopia and just general perceptual conflicts that we can solve for people.
Great. I'm Gordon Wettstein. I'm an assistant professor of electrical engineering at Stanford University. I'm the director of the Stanford Computational Imaging Lab. And our interests range from new types of cameras, LiDAR systems, to displays. In particular, over the last few years, we've been focusing on a lot of new types of VR and AR displays. But together with Nitish, we've been developing also new kinds of vision aids to help people see better in the real world, not only in the virtual world.
That's great. Well, on the show, we have experts from all sorts of fields, and some of our listeners will be more familiar with what's new and exciting in AR and VR, and others won't. Before getting into the specifics of where you guys are kind of inventing the future, can you give people a bit of a sense, maybe they've read about VR and AR in the business press or things like this, but may not be as up to speed on the latest and greatest. Can you guys start with just sharing a few of the newer and exciting things that have happened recently?
Sure. I think the newest thing that's happened is the release of the Magic Leap headset, right? Is there anything newer than that?
No.
Okay. So the new Magic Leap headset, which of course, has headlines everywhere in the VR and AR space because they've raised a ton of money. They came out with their Creators Edition or something to that effect about, 2 months ago? And basically, it's an AR headset. What happens is that you have some sort of a screen that kind of overlays itself on top of the real world so you can interact with virtual objects at the same time that you interact with a real world object. And usually how these displays work is they have some sort of a laser or a projection system that couples into something called a waveguide, which directs the light from the sides where the projection engines are into your eyes. And if you look at other technologies like the HoloLens, which is 3 years old, 2 years old, a couple years old, they usually what they do is they place all of the imagery at a single focal distance, which means that if you want to look at something, you have to look at that distance. So if I'm trying to look at something that's in my hand that's like a foot or two away from me, I can't in the HoloLens because the focus distance is actually set to being further away.
Okay, maybe we should take a small step back and just clarify some of the terms for people who may not be as familiar with the technical jargon.
Yeah, please.
Basically, what Nitish is saying is that traditionally in VR and also AR, the digital content that you see is basically it's a floating plane in space. So the real world that we see day to day is distributed across many different distances. So our eyes can naturally accommodate or focus at these different distances. But for most existing AR and VR displays, the digital content is just shown at one single fixed plane. And you can't really change that after. So some of our work in the past has been focused on how to build better VR displays that can support multiple focal planes to give you a more natural viewing experience. And Magic Leap basically also has a technology that is very related, where they were trying to tackle this problem of just showing digital content at a fixed focal distance, and they can do that at various depths. So that's I think the hottest thing in AR and VR. Oculus also announced a prototype just a few months ago.
Right, the half-done prototype.
Yeah, and they're including some of this technology too. So that's driven by eye tracking and mechanical motion of the microdisplay inside the head mount. And so that's based on some of our earlier research where we demonstrated that really leads to a significantly enhanced viewing experiences in VR. So it's really great to see this. Some of the technology that we develop at the university also migrating into products. But it's a much bigger challenge to do the same kind of thing in AR, where you basically have a small transparent piece of glass that you need to see through because you still want to see the real world. and its digital image, and then support the same kind of modalities that give you high quality and visually comfortable viewing experiences. So I think these focus cues are something that we are seeing more and more in AR and VR now, becoming slowly addressed in terms of challenge. So maybe you can talk about the visual comfort issue a little bit, because we haven't really touched on that either.
Sure. So with visual comfort, usually when people think of putting on a VR or AR headset, they think about how after a while they start to get a little bit uncomfortable because of some sort of a visual discomfort. And the thing that people think about first is actually usually motion sickness, but that's actually a little bit different. It's related to your balance system. What we're going to talk about is actually headaches and eye strain that people get. And this happens because of something that we call the vergence accommodation conflict. And those two words, I'll explain them. Vergence is a word that combines convergence and divergence, where your eyes either converge inwards or diverge outwards to look at the things that are further or closer to you. And then the other word, accommodation, just means the refocusing of the lens in your eye to kind of like a camera to bring things into focus. And if you look at the real world, if you want to focus on anything, basically, you have to verge and accommodate to the same distance. Otherwise, it just doesn't work. On the other hand, if you're looking at a VR display or most AR displays, what you have to do is accommodate or focus to the exact plane where they've placed all of their virtual content. But when you're getting that 3D aspect, what they usually do is they display a slightly different image to each eye, such that you have to converge or diverge to different distances. So you're getting like half the 3D experience from the vergence, but you're missing the other half of the 3D experience from the accommodation. And effectively, your brain kind of gets a little confused, and you get some eye strain because the refocusing is basically mismatched from the vergence. And after a while, this can also lead to headaches, and generally people, they don't necessarily know why something is wrong at this point, but they just don't want to use VR or AR for longer periods of time because of it.
Okay, so basically to summarize that, depth perception or stereo perception is a pretty complicated mechanism in the human brain, and current displays don't really support natural 3D vision. They only support a subset of these cues that our brain uses to see distance, and that makes us sick and creates nausea and eye strain and other problems. And so building technologies that can solve these challenges has been really exciting, right, for the last couple of years, and that's kind of what Magic Leap is also trying to do. Yeah.
Sure. So now I saw the TechCrunch article that you guys were both talked about of VR optics could help old folks keep the world in focus. What were they referencing there with this prototype and everything you've been doing?
So, right. So the VR optics there, it's because, like we've been talking about this entire time, a lot of our work has been on optics for VR to basically take this fixed focal plane in VR and then move it around so that you get the extra focus cue for a refocus. On the other hand, if you look at older folks, what happens to all of us actually is that there's a crystalline lens in our eye. And it actually starts out quite flexible when you're like a child, but as you age, the proteins kind of degrade a little bit, and eventually it stiffens up so that the muscles, when they try to bend it into different focal distances, they just can't. It just stays in place. And we usually call this presbyopia. And people actually think of it as becoming farsighted, but they're actually slightly different processes. But if you've ever seen somebody that's a little bit older, and they're like trying to read a book and they like bring their hands out so it's further away from them, that's basically because of presbyopia. And usually people will use like reading glasses, or they'll use progressive lenses or bifocals. And all of these, we think, are basically trying to solve a problem in a way that's fundamentally different from the way our eyes solve the problem, which is our eyes take a lens that can actually change its focal state around in order to refocus to different distances. But all of these things like reading glasses and bifocals and progressives, what they do is they say, okay, well, we can't change the lenses with like the older lens technology. And so instead, what we're going to do is just have multiple different powers of lenses, and you either have to carry around multiple pairs of glasses, or you'll only have to be able, or you're only going to be able to look through a small piece of your eyeglasses to see different distances. And so with VR, since we have a lot of technology that can move around focal planes with focus tunable lenses or moving displays, we looked at this and thought, well, why don't we try to bring some of our expertise in our area over to the presbyopia correction area, and use these focus tunable lenses where the entire lens changes its focus, kind of like the eye already changes its focus, and try to basically solve the problem in a more natural way. And what that usually ends up being for us is that we also use eye tracking so that we can figure out where they're looking, and a depth camera to see how far away everything is. So it's kind of like a natural solution.
That's interesting. Well, let's do this. Let's take a quick break from our sponsors, and then I have a question about that. Okay, so just before our sponsor break there, I was saying I had a question about this application. So just, I'm sitting here listening, and I'm kind of smiling at how this, as I imagine how this could be. But as a form factor, could this be put into essentially, if it was miniaturized enough, into some sort of headgear, into glasses that essentially are taking care of all that for them, where they're wearing this permanently and essentially electronically it's compensating on an ongoing basis? Is that a correct assumption on my part?
Yeah, so this is exactly what we envision. So the idea is that we have digital or electronic eyeglasses in the future. Simply, eyeglasses are really great today for correcting nearsightedness and farsightedness, but they're not very good at correcting presbyopia. And young people don't really think about this much because it starts affecting people when they're about in their mid or late 40s or early 50s, but you can't escape from it. And presbyopia, again, is this fact that we simply can't focus our eyes at different distances anymore. They're stuck at some fixed distance, and we need different types of eyeglasses to correct for that, but none of them are really ideal. So Nitish already mentioned things like progressive glasses or bifocals or monovision. There are a number of different approaches to trying to correct for that, but none of them are very natural. Because the natural way of looking around and is to have focus just work. Again, this liquid lens in our eye is something that automatically adjusts. You can think about it as an autofocus mechanism. And in glasses, you simply don't have that mechanism. So with the technology that we built, we're trying to emulate exactly this autofocus mechanism. But we need external sensors and the ability to change the focal power of the lens dynamically in order to build these glasses. So we did this with eye tracking, with depth sensors, and also with these focus tunable lenses, and build a control mechanism that works in a quite natural way. Our prototype, as you said, is pretty big right now. It looks more like a VR headset that you can see through, simply because we needed to fix a lot of these types of elements. I mean, it's kind of like the first computer kind of covered an entire room, right? Sure. But now we have all this processing power in our cell phone. And that's exactly how we envision this technology to be miniaturized over time.
Well, on that note, can you actually talk for a bit for folks who maybe, they're thinking about gaming or they're thinking about Oculus or these big things? Can you talk for just a minute about some of the progress that's happening in smart glasses that look like glasses these days?
Sure. So I think the two most recent examples that I can think of are the Intel Vant project, which was unfortunately canceled almost as soon as they announced it. But they were using these things called VCSELs, which are basically tiny lasers that work slightly differently from normal lasers, to basically project the image onto like a small piece of your glasses, so that when you look down into the corner, you would be able to see notifications or some sort of a navigation thing or anything you wanted to show there. And if you look up articles about the Vant, you'll see that they looked a lot like normal glasses, and I think the form factor was quite nice there. Just this morning, actually, I read another article about an Amazon-funded startup by the name of either Focals or North. One of those was the name of the startup, and one of them was the name of the glasses themselves, I believe. But they're doing something really similar, as far as I can tell. They have these glasses that look, at least from the front, exactly like normal glasses. From the side, they've got like a thick frame thing going on so they can house all the hardware. But again, basically they're taking lasers, shining it onto the glasses, and then into your eyes so that you can see navigation, notifications, and that sort of thing. It isn't. I want to note the lasers that people are using are eye-safe lasers, so it's not like it's not going to destroy your vision or anything. The cool thing that I saw about the Amazon startup, or the Amazon-funded startup rather, this morning is that they actually support prescription glasses. I think the article said +4 to -4 diopters. And if you don't know what those numbers mean, there's just prescription. It's a way of describing the lens power that you put on your eyes. So, when you go to the eye doctor and they write down some numbers, it's in diopters.
Well, it's pretty exciting. It's starting to sound like Minority Report or the, what used to be science fiction, right? Well, listen, we've got a couple minutes here before the first half of the episode is over. Can you guys talk maybe a different direction for a minute of the advantages of being a part of Stanford and a part of the lab and how you see that as an advantage for the work you're doing?
Okay, maybe I can try to answer that. Being in Stanford is incredible because we're at one of the top engineering universities in the world, and we actually work very closely with a lot of friends in consumer electronics industry, including Facebook, Google, Apple, all the big companies, Intel also. So we're quite, independent because we're not driven by generating revenue necessarily. We can be very creative in the way we approach problems, but we still work very closely with our friends in the industry to bring it to market. And what that allows us to do is we have this academic freedom, basically, of pursuing problems that are not necessarily 1 or 2 years out because we're not driven by building a product necessarily. We can think about, what are the big challenges 5, 10 years down the line? And we can be, creative about solutions in that space. And we can prototype them in a way that, may not be miniaturized, may not look like a pair of eyeglasses. They can be big. But we can prototype this technology here. We can evaluate it. We can run user studies and really demonstrate what the benefit would be. And then we work very closely with our friends in industry to actually bring that to market.
Yeah, it seems kind of like a dream come true in some ways to not have that constant constraint breathing down your throat of how are we going to make money from this next year?
Yeah.
So I guess to close off here, maybe we'll end with this. When you think about how this work you're doing right now about having these essentially not cause headaches and people being comfortable wearing them for the long term, if you were going to give the 30-second elevator pitch of why that is so important 5 or 10 years down the road, I can make my assumptions, but to you guys, why doesn't one of you give me the elevator pitch of why it's so important to you?
Well, I think it's just really important to see well. And that is true for new types of technologies that are being built to augment our vision. But it's also true for, the kind of, I don't want to say degeneration, but the kind of, degrading performance of your natural optics that Mother Nature gave you. They will just degrade over time. And building new technologies that help people see better, that's great. When I noticed that I actually need glasses because I'm nearsighted, it was a major difference for me, a change in the quality of my life to be able to see images sharply, and simply because I can react in traffic much faster, I can read things better, I can recognize people's faces that I wasn't able to do beyond a certain distance before. Being able to see well is just a big point in the quality of life, and also linked to education in many developing countries. So I think it's very important for people to see well, and we simply are excited about building technologies that help people do that.
Mm-hmm. And on the other hand, for VR and AR systems, if we want to be building ubiquitous computing systems, well, they can't be ubiquitous if they don't work for everybody. And so we have to take into account that different people have different types of vision, that older people's vision works differently from younger people's vision. And to account for all of these in one package is actually quite difficult. And that's what we're trying to solve.
I love it. Okay, guys, thanks for doing this. Everybody, please tune back in for part 2 of our interview. Well, that's it for the episode. One other thing I wanted to tell you about, if you'll remember the guys from Convoy in episodes back, Ken Free and Trent Mano, I went on one of their CEO trips to New York, and I met a guy named Brent Thompson, very successful entrepreneur. He was former CEO of Jive Communications, big company now, I think $300 or $400 million. Anyways, he started a new company called blipbillboards.com. I'm super stoked they're a sponsor now. But I remember a year and some ago when I met him, I thought it was genius. Instead of having to buy 6 months or a year's worth of billboard for thousands of dollars, you can buy 8 seconds at a time for like 10 or 20 cents. You pick what billboard you want it on, what time of day you want it to run. And it just puts so much power in the hands of marketers and CEOs who want to try something and see if it works. You can buy as many or as few as you want, change it as many times as you want. I think now our podcast is being advertised on billboards in like 18 different states because we have these guys as sponsors. We're pretty excited about it. Hope you check out blipbillboards.com. Thanks.